Dear students, let us continue with the discussion of bioavailability protocol. The first content is study objective. The objective of bioavailability study only decides the bioavailability study protocol. Why? Because, for example, a study design meant for estimating essential pharmacokinetic parameters differs significantly from a bioequivalence study meant for comparing the test formulation with a reference standard. Coming to study design, we know that various factors have to be considered in conducting a bioavailability study. Because the rate and extent of drug absorption into the systemic circulation and its distribution and elimination are influenced by a variety of factors like the subject factors such as age, sex, disease state, food habits, general health condition, body weight of the subjects, as well as the experimental design, route of administration, time of administration, sampling, the time of sampling or the frequency and duration of sampling, the analytical methods used for analysis of samples collected, and the compartmental model used for estimation of pharmacokinetic parameters or bioavailability contributes to the observed blood concentration time profile. Therefore, it is necessary to consider all these important factors in study design. Okay, while enumerating the contents of the bioavailability protocol itself, I told you, what are the factors that are to be discussed under study design, or what are the factors that influences the decision regarding a study design. Okay, I just repeated all those factors once again, and so let us discuss those factors one by one. Coming to the first factor, the experimental design. Okay, the experimental design used for conducting a bioavailability or bioequivalence study. Mainly two types of designs are commonly used for bioavailability studies. First one is parallel design, second one is crossover design. Between these two, parallel design has less utility when compared to that of the crossover design. Why? Because this design cannot correct the intersubject variation or intersubject variability, cannot overcome the problem of intersubject variability, okay, during the study, and has been proved beyond the doubt that most of the times the intersubject variation becomes greater than the variation between the formulations. Okay, so I already told you that we need to only assess the differences due to formulation or formulation factors, but not due to the other factors. Okay, if at all other factors are affecting, we have to minimize them or we have to eliminate them. So here, if we use this parallel design, okay, then there are more number of chances for the intersubject variability becoming greater than that of the variability due to formulations. So for these reasons, parallel design is very less used, and instead of it, a crossover design is preferred in bioavailability or bioequivalence studies. And this crossover design, okay, minimizes the effect of intersubject variability in the study by using each subject as his or her own control. Okay, this crossover design overcomes the disadvantage of parallel design by minimizing the intersubject variability in bioavailability study by using each subject as his or her own control. Okay, and we have two types of crossover designs. First one is Latin square crossover design, and the second one is balanced incomplete block design. Coming to Latin square crossover design, it is a standard approach for conducting a comparative bioavailability study, and in this study, this study is sorry it, this study uses a randomized balanced crossover design, which is called as Latin square or complete crossover design. Another name for Latin square crossover design is complete crossover design. In this design, each subject receives each formulation just once, and each formulation is administered just once in each study period. I repeat once again, in this design, each subject receives each formulation only once, and each formulation is administered only once in each period. So depending upon the number of groups involved in the study, we can classify this Latin square crossover design. For example, if we are conducting the study with two groups, wherein each group contains 6 subjects, we can call it as two-way crossover design. If we use 3 groups for the study, we can call it as three-way crossover design. If we use 4 groups, we can call it as 4-way crossover design. So like this. And if we take a two-way crossover design, 12 subjects are used to study the bioequivalences between two formulations, for example A and B. During the first study period, subjects from 1 to 6 receives formulation A, while the subjects from 7 to 12 receive formulation B. A second study period is initiated after a washout period. Nothing but there will be 2 study periods. In the first study period, first group of subjects will takes first formulation A, and second group of subjects takes formulation B, which is followed by a washout period, and washout period is followed by a second study period, wherein the first group of subjects takes formulation B and the second group of subjects will take formulation A. So in this way, each subject takes only one formulation. Sorry, each subject takes each formulation only once, and each formulation is administered only once during each study period. And we have various advantages of using this Latin square crossover design. As you all know that we are using this design for minimizing the intersubject variability by using each subject as his or her own control. Apart from this design minimizes the carryover effect which could occur when a given dosage form influences the bioavailability of a subsequently administered dosage form, since each formulation is preceded and succeeded by the other formulations or dosage forms. Okay. Means since we are keeping a washout period between the two study periods or two treatment periods in this design. So during this after first treatment period, the drug that is present in the body, that or the drug that remain in our body, gets eliminated completely. So, okay, so that it will the amount of drug that remains in the body at the end of washout period almost becomes zero, and the effect of and there will not be any effect of drug remaining in the body administered in the first study period and the drug administered in the second study period. Okay, so the effect of drug administered in the first study period and the drug administered in the second study period can be called as a carrier effect. So since we are using washout period, there will not be any carryover effect, and this design also minimizes the time effect on bioavailability, since each dosage form is administered in each study period, and this sort of design requires less number of subjects to get meaningful results. So these are the various advantages or benefits by the use of this kind of design. And apart from the advantages, this use of this design also leads to certain disadvantages or drawbacks. So as the number of formulations to be compared or to be tested increases, the total duration of study also increases. As the number of formulations increases, the number of study periods increases, and number of washout periods also increases, which leads to increasing the overall study period. And suppose if the drug under suppose if the drug under study is having a higher biological half-life, that too affects the total duration of study. Why? Because that further increases the total duration of the study. So due to increased study period, subject dropouts may take place, and At last, the medical ethics also not allow too many trials on a subject continuously for a long period. The medical ethics will not allow collection of too many samples for a long period of time from the subjects, unnecessary exposure of drug for a long period of time on subjects, etc. So these are the various drawbacks of using this kind of design. And so this is about Latin square crossover design. So we'll discuss about the other design, it is balanced incomplete block design, in our next video. Thank you.